Okay, so this is probably the hardest question that we're going to do in this whole thing because you're resolving two systems on a slanted plane. Now, before I start doing anything with this, I'm going to look over here at what I have and start thinking about what I'm probably going to need. So I know because of the way that the question's worded, and I hope you've paused it and read it for yourself, I'm going to have one going in that direction, one going in that direction, and then I'm going to have another vector going in this direction and a vector going in that direction to resolve the system. So now that I've done that, I'm going to start reading the question, which is probably what I should have done to start off with. A car with a mass of 1,400 kilograms is pulling a caravan with a mass of 2,850 kilograms up a slope with an inclined slope 1 in 4. Now, as soon as I see that, I know that that means sine theta is equal to 1 over 4, which means that theta is equal to the inverse of sine 1 over 4, which means that theta is equal to, now make sure that your calculator is in degrees or this will not work out for you. So 14.48 degrees. We'll go to 2 decimal places, why not? Okay, so a slope of 1 in 4. The resistance to the motion of the car and the caravan are both 1/4 of their weight forces. So this one here, R1, is going to be equal to 1/4 of the weight force. Same for R2 is going to be 1/4 of the weight force here. Now, determine the tension in the tow bar and the tractive force exerted by the car engine if the car moves up the incline with an acceleration of 1 meters per second. Now, if we're moving up the incline, this has to be the car. The caravan does not tow the car tows the caravan. Okay, so that means that if we're calling this R1, then that has to be 1/4 of 1,400 G, and then this one has to be 1/4 of 2,850 Gs. Okay, so now we can start looking at figuring out these systems. So I am going to resolve these systems. I'm just going to draw on my diagram. Look, I'm going to run out of space, but you probably won't, and that's fine. So remember that this one here is this one here. Okay, and this angle in here is going to be 14.48 degrees, meaning that this is the opposite side. So it's going to be 2,850 G sine 14.48. Okay, and this one up here is going to be 1,400 G sine, again, same angle, 14.48. So when I whack them in the calculator, I'm going to get some answers. Okay, so this one here is equal to 6794.71. This one up here is going to be equal to 3,337.75 Newton's force. Now, the reason why I'm resolving them is because I don't really care about what's happening up and down. If the acceleration's going that way, then I care about what's going that way. Now, let's start resolving these forces. Doesn't matter which one I start with, I just need to pick something. So we're going to do this one first because, first on the page, why not? So let's work it out. Force is equal to mass by acceleration. Now, I'm going to state that the other way around because I'm going to have more on this side than I am on the other. So the mass of that one is, the caravan is heavier. So 2,850 times the acceleration, which is 1, is going to be equal to, now I'm only looking at the forces that are here. So this one, and this one. Now, in this diagram, acceleration is positive that way, so we're going to be looking at T minus 6794.71, which is this vector going in this direction here, and it's negative because it's going the opposite way to our acceleration. And then we're going to also subtract the resistance force. All right, so in my calculator, I've done all the hard yards. So it'll be 2850 plus 6794.71 plus a quarter times 9.8 times 2850. Okay, and that gets me 6627.21 newtons of force. Okay, so let's move on to the next part. So now we've worked out the tension in this string here. Now we can start to look for the force moving up the plane, which is now this one. So I want that, and that. So I had to calculate T to be able to work out F. If I'd gone for the other one first, I would have seen it worked out to be simultaneous equations, and then I would have just gone with that. So mass times acceleration is equal to the force. In the second diagram, the mass is 1400. The acceleration is still 1, but my force is now equal to, this one is the only one going in the positive direction. So F minus T, which is 6627.21, minus this one here, 3337.75. Now, you could write this in place of this, but I am lazy and I keep running out of space on my little talkboard. So all I'm going to do now is chuck this in the calculator and work out what F is equal to. So the force in this thing is 21,364.96 newtons of tractive force pulling the car up. Now, I do believe that my answers are slightly different to what the textbook got, because the textbook didn't have any rounding errors. Good hustle, everyone.